Given to you is x is a real number, yx is the solution to this differential equation. One condition is given to you, and what are they asking you? Maximum value of this function. So what do? First find out the function. Later we can find the maximum value by finding critical points and so on. So how do I solve this differential equation? It is very clear that you can form a linear differential equation out of it by dividing by x square minus 5 throughout. Okay, and when you divide by something, just make sure that that particular thing is not 0. That means when I'm dividing by x square minus 5, I should assume that x square is not equal to 5, right? Because you can see when x square is equal to 5, that means x is equal to plus or minus root 5. You can plug in the value to get what is the solution. If you plug in here, you will see that this is 0 and this is also 0. You will get y to be 0. Okay, so when x square is 5, then my solution is y is 0. So we will not bother that x square is equal to 5. We will assume that it is not 5. Okay. Now, how do we solve a linear differential equation? How does it look like? No, right? This is a linear differential equation. It looks like this, and the solution is given like this. Okay, e to the power integral p dx is called the integrating factor. So, in our situation, what is my integrating factor? What is e to the power integral p dx? Let's try finding out. What is my p? This whole thing is your p. Minus 2x upon x square minus 5 dx. Okay, integration is not a problem because you end up in getting minus log mod of x square minus 5, right? We have to put a mod because x is any real number. We don't want this to be negative. Log of negative is not defined. So you end up in getting the integrating factor to be 1 over modulus of x square minus 5. So normally we don't want the modulus, right, to write the solution. So we take cases. Okay, case 1, like you will get if your x square is lesser than 5, then this whole thing will be negative and you end up in getting negative 1 over x square minus 5. And if x square is greater than 5, then you end up in getting 1 over x square minus 5. So let's call this case 1 and let's call this case 2. So let's write the solution with both the cases. Now let's write the solution. This is your solution, right? Y times the integrating factor. So y times the integrating factor is equal to integral q. Who is your q? This, right? So minus 2x x square minus 5 times the integrating factor. So this is and plus a constant. Okay. Now things are very simple. This gets cancelled. Minus minus becomes a plus, and you are left with minus y over this is equal to x square plus c. So simple, right? Now how do you get your c? By putting this condition which is given to you that y2 is 7, y at 2 is 7. I can use that, right? Because x is 2 is here because 4 is lesser than 5. Okay, so I can use that and get the value of c. So I'm going to put y value 7 and x value to be 2. So 4 minus 5, that is negative 1. 4 plus c. So from here you get the c value to be how much? 3. So final solution is what? Final solution, if you write from here, y is equal to, instead of c you are going to write a 3, x square plus 3, and you would cross multiply x square minus 5, and this negative sign also you take it here. This is your solution for case 1. If you want, you can just try multiplying and writing. It will be x power 4 and then minus 2 x square and then minus 15. That's your solution, right? Okay, now looking for the max value, right? In this case, let's get done with that. If I want to find max value of this function, I need to find the critical point. And what's the derivative? 4x cube minus 4x. Or you can try taking out 4x outside, you get x squared minus 1. Very simple, right? What? You can factorize it further, x plus 1 and x minus 1. Now what are the critical points? 0, negative 1 and 1. These are the critical points. And how does my derivative changes sign? See, minus sign is outside right here. So you have to start with a negative and use your wavy curve. Negative, positive, negative, positive. That means your function is increasing, decreasing, again increasing and then decreasing, right? Derivative positive means function is increasing, derivative negative means function is decreasing. That means 1 and minus 1 both are what? Maxima point. Okay, and you can see function is an even function. Okay, the function you got is an even function. So at both the points you will get the same function value. Okay, so and 1 is here in this case, right? 1 is here, 1 square is less than 5. So the max value you are going to get is at 1. And what is f of 1? Just plug in here. What is f of 1? Just plug in here. You get minus of minus 4, and then this would be 1 square plus 3, that's also 4, that's 16. So your max value looks like to be 16, but then you have to also look for the case number 2. Okay, do we get a max value from there? Let's see. Case 2 is when your x square is greater than 5. The only change will happen that your integrating factor will not have this negative sign. So it would be like this, upon x square minus 5 is equal to, okay, everything here same. Can you see? You just get a minus x square here, x square, and constant remains the same. It's a constant. Okay. So you finally end up in getting the y value to be x square minus 5, and if you want to take that minus out, you get x square minus 3. Okay, so your function looks like x power 4, and then I guess minus 8x square, right, and plus 15. Now here also let's find the derivative, let's find the critical point. What do you end up in getting? Minus 4x cube minus how much? 16x, right? Yeah. So and then you can take out 4x outside, right? Okay, now you see the critical points are what? X is 0 and plus minus 2. None of them lie in this particular case, so you don't have a critical point for this. Okay, so your final answer remains to be 16. F of 1 is 16 or f of minus 1 is 16. Your max value is 16. Right? I will see you another question very soon. Bye bye.